Hello everyone, welcome back to the channel. I'm Swati and I have about 3 years experience in the VLSI industry now. Today we have Hardik Trivedi with us, a passionate DV engineer. So let's hear from him about his journey and get some useful tips on how to become a successful design verification engineer. Over to you, Hardik. Can you introduce yourself?
Thanks, Swati, for this platform to share my experience and knowledge about verification to your audience. Yeah, so I am Hardik and I'm basically from Gujarat, India, and currently working at Intel Malaysia. Yeah, so I started my journey as a VLSI engineer, and at that time I thought like it's just a coding, nothing more than that. But later on, when I started working in the industry, then I realized that it's not only about coding, it's all about mindset. Verification engineers are more creative and more passionate about finding loopholes in the design. Really amazing journey as of now. So earlier I worked in Samsung Bangalore as a staff verification engineer. That time means I worked on mostly on SoC verification. Right now I am IP working on IP verification.
So like it will be entirely different, right? The
Yeah.
level of verification you do at the SoC and at the IP. So
Yeah, so major difference about IP verification and SoC verification are like in IP level, you need to understand each and every detail of one particular protocol. IP means it's a protocol, there's set of rules. So we need to follow those set of rules as per written by third party or architect who designed that particular architecture, and that set of rules we need to follow. And if it's not follow, means there are bugs in the design. We need to start understanding specification in such a mindset that we need to break the design. It should not work properly. In that way we need to write our scenarios, or we need to thought about those scenarios. So that's one of the thing in the ip verification. In SoC verification, it's a completely different challenge. It's like it's a real time, like see, system level scenarios are there. For example, you are having your US pen drive and your laptop is there. So in that laptop you are setting up, means you are simply plug in your pen drive and you are copying some data from your pen drive to your laptop. In between, you are simply removing your pen drive, or for example, in between your battery drain of your laptop, right? So at that time means entire data is not transferred. Then that kind of scenarios are like real time system level scenarios are there. So those are the SoC level kind of thing. But whenever we are doing IP level verification, we also need to think about those kind of system level scenarios. Then we can reuse some of our scenarios in the when we are simply integrating our IP level, means IP stuff to the SoC, then it will be reusable.
So, currently you're in working in IP level, right?
Yeah.
And can you share about like where you're working and how you got
Yeah.
like
So
I got
currently
to know
I am
you're working in Malaysia.
Yeah, so like currently I am working on Intel's own IP, their own proprietary, and so I cannot share more detail on that. But yeah, so the main thing is about Malaysia is like work-life balance is better, and it's a kind of cool team. We enjoy here much.
They have less office hours in a week. Is it like here we do almost like 8 hours a day or something, right? In Bangalore.
We we are in VLSI, so it's always more than 8 hours, 10 hours. So nothing like that. If you are passionate in, if you are really love to do what you do, then means you don't
Doesn't
feel
matter.
burnout. Yeah.
So can you share about your journey? Like how did you transition from India to Malaysia? Like how did you go about with this job switch?
It's like there are multiple ways, like you you do your masters here, and as an intern you start
Mm.
working here. So that's one of the way. Another is like if you are having more than 5 years of experience, you will get more
Mm.
opportunities because any company want international engineers for their talent and their skills, right? So and experienced people having that those kind of skills. And another way is like this is for direct entry to the product organization.
Mm.
And if sometimes as in like from service companies also, like they are also providing this kind of support to work on site.
Okay.
And that's a like for Malaysia, Singapore, it's quite easier than US and other countries.
Currently, like Malaysia also, I see many openings.
Yeah, here like means earlier it was only Intel in the Malaysia,
Mm.
but these days Intel also facing competition here. So they are having like AMD, then Microchip, Micron, and few more all are also coming. So they are having also quite good amount of opportunities.
Let's move into like how to prepare. Like when I started as fresher, I prepared for digital design, Verilog, STA, all these concepts. So, what do you tell like for becoming a good engineer in DV field, or like for when you go for job switch and all? What are the main things you should focus on?
Yeah, so if I am taking an interview of a fresher or experience level, both are having a different kind of
Mm.
interviews and challenges. So as a fresher, uh, I'm mainly focusing on like digital electronics,
Mm.
then basic programming knowledge. Like if you know the digital electronics, then you should convert it to either Verilog or some C programming as well. So those are the basic requirement. And another like solving skills, like uh, if if some problem I am giving, then are you able to do that, or what's your approach?
Mm.
Sometimes I am not looking for your entire solution, but I am looking for if I am guiding you little bit, are you able to complete those stuff or not? So mainly like as a fresher, you should in if you want to enter in the verification, then digital electronics is must. Verilog, system Verilog. UVM, if you know, it's well and good. If you don't know, then that's okay. You will eventually learn. But system Verilog is must because in the background of UVM, system Verilog is there. If you understand system Verilog, you can easily map it to the UVM. But main important thing is like those are the starting criteria. And once you enter into the industry and you work with experienced people, you will also understand how to develop mindset, how to read some specification written to high level specification written by architects, because you also need to translate those kind of language into your own understandable language, and then you need to write some scenarios. And so whatever technology we are seeing around us, it should be a bug free. Otherwise, single bug cost much more money as well as lives.
Yeah, all of the chips are going to real time, some applications. So,
Yeah, for example, like if you are working on autonomous chip, and if that chip having bug and it's installed in your car,
mm,
and at some point of time if it's having bug and it's not working properly, it might cause your life, right? So we need to think like that, like it should be bug free.
uh, yeah, I also went through your blog on like about design, like more about apart from design, how verification is important. So it was really interesting. Can you share some insights on that?
Yeah, so like I started that blog in COVID time because I thought like freshers don't know what exactly industry expect. You are understanding some D flip flop, then what's its application, how you can use it those flops into the real time chips, right? So those kind of things industry expects, but it's not in our curriculum. Our curriculum, it's all about do some stuff and get the numbers. But that's a complete industry expectation is different, and means our learning curriculum is it's a different thing. So for that purpose only I started that blog, that how to develop that kind of mindset in whichever language you are working. Language eventually you will learn, but you will not develop that kind of mindset later on. So for that you need some guidance, some mentorship, and some your own thoughts. Like if you are having some RTL design or some circuit, you need to write how creatively you break that design. You are having some set of rules. You need to go some random things, some negative scenarios, some straightforward scenarios, cross off all kind of scenarios. For that mindset, if you started with completely open mind and more of like I want to break this design, it should not work straight away. Then only that creativity comes, right? And sometimes we don't want thousand of test scenarios. You can verify those that design within 100 test scenarios with so much effective effectiveness. So that matters. So for that you need some, like eventually you will learn with experience and while working with experts, but you need to work hard on that. That's more important and challenging than just to learn a simple language.
Apart from studying, like you suggest some important projects or something that anyone should do while preparing, so they get into this mindset, like project or books or something
Yeah,
like
so
that.
like some you can start with some, for example, in verification, one important thing is how to develop test bench and how to develop components, right? Verification components. So you can simply start with like some counter design or some FIFO design. You, as a fresher, you can start with that. For example, FIFO having set of rules, right? Some full, empty, half full, half empty, and so those kind of, so those are the specifications. You need to verify in all condition it should work fine. So you can start with that. Then later on, once you are comfortable with that, you can go with some better protocols like APB, AXI, AHB. Those are there. So and those specifications are openly available to everyone.
For entering to any verification plan is like major, right? The first thing that we
Yeah.
start is verification plan. So how do we go about writing a verification plan? And if we are working in a particular domain in verification and you want to job switch, will that domain matter? Like if you have done verification of CPU and you want to go to memory, is that all? Does that all matter when you are switching jobs, or it's fine since anyway we would have learned
No,
verification?
it doesn't matter just because you are experienced enough to verify particular stuff, right? So it means you know the languages. You are having that kind of mindset to verify anything, right? So it simply design changes, project changes, but that mindset and that skills remain same. So it doesn't matter if you switch from one project to another project or one company to another company. It's all about like how good you are in verifying any stuff.
Hmm.
So that's only so that's why I told you will learn different languages eventually, but that mindset matters. If you are really tough with your mindset that I can verify any stuff, so you are good enough. What other question? I forgot that.
About verification plans.
Yeah, verification plans are like it's it's comprehensive. It's the most important document for any verification engineer. So like whether it's a junior or senior, because whenever they start, it starts with verification plan. You are having some specification, then you will also figure out like how to verify those features, then which all features you need to verify. Those all information are there in the verification plan. Then you are having existing test bench or you need to develop some additional components in the test bench. Then what components you will need to update or you need to add and plug, right? So those all information that in the verification plan. Then what kind of test scenarios you can think of th- to verify that particular feature or multiple features. So those sequences, those scenarios are there in that verification plan. Then what kind of checkers you will keep, like, and those checkers are having different kind of checkers, like assertion checkers are there, system verilog checkers are there, what kind of monitors are there, right? Whether you eventually use existing monitor or you will reuse the existing monitor as a passive component or active component. So those kind of information, each and every detail to verify RTL design, it's a verification plan. So what kind of coverage you will have, like you will have test plan, coverage plan, assertion plan, all together in one single document. It will be your verification plan. So that's the after specification, this is the most important document for any verification engineer.
And like in verification domain, what all are like the career opportunities? First, maybe use IP is one, SoC is one. Then we can move on to pre-sale and post-sale also in the same like this. Is it like among for the same person we can go on to till that
Yeah,
level or?
yeah. So see, it's like uh, I you can switch IP level, subsystem level, SoC level, full chip level. So
Mm,
you can switch in between anytime. But
okay.
if you, like, for example, you are good enough in verifying and verifying any design, and if you are good enough to think of a different kind of scenarios, then you can switch anytime and any kind of design. But most important, are you really up for that challenge, or you just want to be a comfortable in one particular place? So that kind of thing is there. Otherwise, it's like you can anytime switch, and it's means I prefer like one should work on each and every aspects of verification. So they will understand. If IP level verification engineer move to the SoC level, then both are having a different kind of mindset. One is thinking more system level, one is thinking more detail oriented protocol stuff. So if one should work on both the things, then he will be think of more kind of scenarios, and he will be more creative.
Thanks a lot, Kathy. Do you have anything like to tell for someone who's entering, like something motivating or something?
Yeah, means one important thing I want to share is like in VLSI we are having amazing kind of tools. So never shy to experiment any kind of thing. The tools are really friendly, like they will not crash. They will simply saying you are having error in this particular file in this particular line. So those, so don't never shy to experiment and keep on learning on that way. You seem, and if you feel like I need help, just go to your mentors or seniors and ask for help. I want to learn this. How to learn? How to approach this specification understanding? How to approach debugging skills? Right? Debugging, it's one of the important skill in the verification, because 70% of time we are spending in debugging only. 30% of time we are spending on developing. So debugging also, eventually you will learn different ways of debugging. But how to debug, how to approach one particular kind of issue, right? And so for that you need some help from the seniors or some mentors. So never shy to ask. Just one only thing is that keep on learning, keep on growing. No need to worry about anything, just learn.
Thanks a lot, Hardik. We actually got to understand lots about the verification. Like it is very good to hear from experts in the industry who are working.
Yeah, thank you so much for this opportunity. And like, I am really happy to share my experience and my knowledge to the people who are really new to this industry. I hope this will help them.
Sure. I hope even the viewers got to understand and know lots. Stay tuned, everyone. We'll post more such videos and we'll try to get more information about the industry that will help every one of us to become better at what we do.